with enormous energy. But where does all this energy come from? The answer to this question was first suggested by Albert Einstein in his special theory of relativity. Einstein suggested that mass and energy are really two forms of the same thing, and each can be converted to the other. According to Einstein, the equation E equals mc squared relates energy to mass times the speed of light squared, which is an enormous number. So even a tiny amount of mass multiplied by the speed of light squared could be converted to an enormous amount of energy, according to Einstein. By comparison, when a fuel like gasoline is burned in the engine of an automobile, it combines chemically with the air to produce relatively small amounts of energy for travel, along with exhaust products. If the same car could convert the mass of gasoline completely to energy, you wouldn't need an exhaust system because there would be no waste products. Imagine driving up to a service station and saying, "Fill her up, please, with 1 drop of gas." That single drop would take you not just to the next corner, not just to the next city, but it would allow you to drive the car for its entire useful life. Unfortunately, it is impossible to convert matter completely to energy.
This is the Opel P1 experimental car. Much like it was in its day when it was used, it still has the same paintwork, still the same applique stickers on it. It's very, very original. I bought it because I think it's a milestone, and I think it represents kind of where the world has been and where the world is going. Hi, I'm Evan McMullen. I'm the manager of Cosmopolitan Motors in Seattle, Washington. We specialize in automobiles of historical importance. On the test track in 1973, it came in at 376 miles per gallon. I kind of questioned it. I thought, is this really the case? Is this really something that is true? And I did a little research on it, and certainly it was documented very, very well as being the car that did achieve that. And then the more I looked at it, the more I thought, this car isn't even that special. And this was owned by Shell Oil Company, and it was a series of engineers who had done the work on it as part of a competition between themselves, and this was the one that finished the best. It is out of gear now, but it's still pretty dead.
Any gas in the tube up there?
Well, that's enough gas to drive it 10 miles.
Oh, okay.
I thought it was very representative of ingenuity at the time, and a little bit disappointing when you consider that the OPEC crisis initially happened in 1973, really when this car was being formulated by these engineers, and here it is another 15 years later, or excuse me, 25 years later, and we've still not been able to, 35 years later, come up with anything any better. You go back to Henry Ford's original creation, and it got 20 miles to the gallon easily. Here we are in 2008, and we're not able to achieve an average of 30 miles to the gallon in the United States. Certainly worldwide it's maybe that, but not a lot better. Here's a car that got 10 times that much in someone's spare time in their garage. Why is it so impossible for us to achieve something like that today? It's a 1959 Opel Caravan station wagon that's been modified into kind of a pickup look that started off just as a conventional passenger car. a modified drive system and a heating system to vaporize the fuel, ultra insulated and made quite lightweight, but still weighing in at 2,500 pounds.
2,500 pounds,
Yeah.
which is not very light for a...
It's not light at all, yeah. The creator of this car is very quick to discount its performance as being isolated for a track and not being something that can be done on an everyday basis. But I still think there's many things that can be learned from this car, even if there are only a few things that you can apply to a current modern car with all the conveniences that you would want. But what it does have is the ability to get tenfold the mileage that we're normally getting now. So certainly we could expect to achieve 100 miles per gallon, I would think. So the first thought that most people have is this really can't be true. And the next thought is sometimes a little bit of anger, that they're frustrated that there hasn't been more done from industry and from government to try to enforce this kind of research.
Man had released energy from within the atom in the first atomic blast. One of nature's greatest energies hitherto undreamed of, and creating which have confounded mankind. We are apt to think of atomic energy as something new. But God placed this fabulous energy in every bit of matter when he created it. In fact, the earth has been warmed and lighted by atomic energy from the beginning, for the energy of the sun is atomic energy. No, atomic energy is not new. But now that man can control and energy, the world is faced with problems. But the question arises, just what is atomic energy? Well, let's begin back at the beginning. Perhaps it can be said that the cornerstone of our knowledge in this atomic age was laid back in the year 1905, when an unknown clerk in a Swiss patent office scribbled strange equations at his desk. Here, about half a century ago, Albert Einstein gave to the world E equals mc squared. Energy, the equivalent of mass. A radically new conception, key to the atomic age. The idea expressed in E equals mc squared is actually quite simple, but it has caused a great revolution in scientific thinking. It means that any object, this desk, pencil, piece of paper, just any bit of matter represents an unbelievable amount of energy. For example, the atomic energy in, just the paper of this book is the equivalent of the power produced by Hoover Dam in 1 full year of operation, enough to supply the electrical needs of your home for 1 million years. Air is a fragile thing, yet in a single breath is energy equivalent to the burning of 200,000 gallons of high-octane gasoline, sufficient fuel to fly a giant 4-engined airliner to the moon. Within just the paper of this railroad ticket is enough energy to power a cracked diesel-electric streamliner 3 times around the world. In fact, the atomic energy in 1 pound of any kind of matter, a pint of water, for example, is the equivalent of the burning of 1.5 million tons of coal. Now, of course, this doesn't mean that you can take a pint of water and pour it in the gas tank of your family car, take off on a trip around the world, but the energy is there, hidden down inside the tiny particles of which all matter is made. In order to understand this properly, we must know something about the structure of matter. Matter may exist in any one of 3 states. The same substance may be either a solid, a liquid, or a gas, depending upon its temperature and the pressure. Water is a good example. It may be a solid, ice, or a liquid, or a gas. But even in the gaseous state, it's still H2O. What do we mean when we describe water as H2O? And what does all this have to do with atomic energy? Well, to grasp what this simple formula really means is to understand some of the basic laws governing the structure of all matter. Electrolysis apparatus will help us understand why the chemist has called water H2O. The glass tubes of the apparatus are filled with water from the reservoir above. At the base of the tubes, an electric current is caused to flow through the water from one platinum-tipped electrode to the other. Immediately, bubbles of gas form and go streaming upward. Graduated scales on the tubes indicate the proportion in which these gases are released. On one tube, we read 20. On the other, 10. The greater amount of gas burns with an almost invisible blue flame, hydrogen. The other gas causes a glowing splint to burst into flame. This is oxygen. So we say that water is composed of two gases, hydrogen and oxygen, combined in a proportion of 2 to 1. Two particles called atoms of hydrogen are combined with one atom of oxygen to form a molecule of water, H2O. Two colorless, odorless, invisible gases combine to form a liquid. Individual atoms of any substance are much too...
This is the shuttle's fuel tank. It may only be 130 miles to space, but to cover that distance, the engines will use 500,000 gallons of fuel. And that works out at 2 feet to the gallon. Despite the cost, however, NASA does need to test these engines once in a while. So they built this place in the wetlands of Mississippi. The first thing they installed was a huge loudspeaker, through which they played white noise to simulate the sound of a rocket. They then sent a number of trucks in different directions out into the wilderness, and the drivers were ordered to stop when the noise levels became acceptable. This gave them an imaginary boundary line, and anyone living on the inside of it was offered a simple choice. Stay, and you'll never hear another television program as long as you live. Or take the NASA shilling and get out. No one stayed, and NASA ended up with exactly what it wanted. 125,000 acres of nothing. They even had to move 5 cemeteries, because the noise they were planning on making would wake the dead. Don't worry if you can't hear what I'm saying. I couldn't even hear myself. This is the loudest sound you could possibly conceive. And, as it turns out, the cleanest. Now, the most amazing thing is that that cloud up there, which was generated by the engine, is just a mixture of hydrogen and oxygen. It's water vapor. And in about an hour's time, someone in Mississippi is going to get wet washing. It will actually rain. I told you! It's raining! That's unbelievable! Oh, NASA's playing God. It's making its own weather.